Hey everybody, this is an intro video for section 1.2. A little bit of what we were talking about last meeting has to do with what's going on right here. So basically, once again, what we're doing is, if I get this going, let me get the right tool up here. Okay, wrong guy. That guy. Okay. Ready? Begin. Okay. So we're taking a system like this and we're turning it into an augmented matrix. And then we're taking the augmented matrix and using row operations to get it in, well, what we are calling reduced row or row echelon form. Okay. My first question is, what were the row operations that were used in order for this to happen? From last time, you might remember that I worked column by column, and I wanted the first column to disappear the numbers below the one in the upper left-hand corner. So you might, upon consideration, go, maybe what you did is like you did before, -2 times row 1, add it to row 2 and replace row 2 with that. And likewise, take row 1 as it is and add it to row 3 and replace row 3 that way. Okay? And you would be correct. From here to here, it's kind of funny. You can say different things. Like, for example, maybe what we did is we took row 2 and hit it with a 1/5 like we did before, and that we will replace row 2 with that. So we scale. That's another move. If you multiply by a scalar like that, a number, it scales the size from doubling or 1/5ing or whatever. And we use that guy maybe, or you could do a different way. This is going to be weird. I'm going to go, how about we go minus, what would it be? 3/5 maybe, row 2, add to row 3, gives you a new row 3. So the point is that hopefully we're able to get our matrix in row echelon form or triangular form. That's a good thing. Let's talk about something new. Let's talk about what the book calls and the subject matter calls pivots and pivot positions and pivot columns. This goes a long way. It's used in all kinds of fields. Let's take a peek. When you are starting out to row reduce this thing, you're going to use this number 1 up here in the upper left-hand corner, and you're going to knock out and make 0 the numbers below it. Okay, well, that is what they call a pivot position. That is, the number 1 is a pivot position. You used it to knock out those numbers below it. Okay, when you got ready to do it again, you might use maybe this guy as another pivot position. And by the way, when you're done, they are still hanging out, although the 5 you divided to make it into a 1, there they are. Those are still your pivot positions, and there are 2 of them. Okay? And the columns that they stand in are called pivot columns. Now, okay, so that, whatever, but when you get to theorems and they say, hey, there's this many rows and there's this many pivot positions, what does that tell you about the matrix? We're going to understand what a pivot position means. One way to describe it is if you go down through the rows, the very first non-zero in the row is a pivot position. So if you go to row 1, that 1 right there is the very first non-zero. You go to row 2, you have to go 2 in to find the next non-zero, and then row 3 is all zeros. So there's only 2 pivots. What does that mean to us? Well, now let's talk about free variables and basic variables versus pivot positions and columns. The free variables, if this were, say, this system up here, x1, 2, and 3, let's write that in. This is x1 column, x2 column, x3 column, and there you go so far. These 2 guys have pivots, and hence they're called basic variables. You're going to hear a lot about the other guy, though. I'm going to put him in another color because he's special, right? But the column without, there is no pivot in column 3. So therefore, This is what they call a free variable. You'll see why in a second. So what variable is that? Well, column 3, that's x3. For the basic variables, what are they? x1 and x2. They're basic variables, and the free variable is x3. So finally, believe it or not, we're almost done here. What's this mean to us? Well, let's cruise down. Finally, let's express the solution. Okay, if you take the bottom row, remember we were doing this, we're solving back substituting and stuff in class early on Tuesday, well, today. If you take this guy, it says, remember this is x1, x2, x3. It says that 0x1 plus 0x2 plus 0x3 is equal to 0. Essentially, it just says 0 equals 0. I'm gonna ask you to hearken back to algebra when you're solving an equation and you get 0 equals 0. You might not remember, but the teacher probably said, well, that means there's all real numbers is the solution, or any number will work. And you're like, if you say so. And that's what this really says too. It says 0 equals 0. Well, that's true. And what it's going to tell us is that we have an infinite number of solutions. So we're almost done. Watch this. The middle row says 0x1, and then it says 1x2 minus x3 is minus 5. Now watch out, don't blink. So x2 is equal to x3 minus 5. Okay. No one said what x3 was equal to. We can't solve for x3 because the third row was nothing. It was 0 equals 0. And then finally the top row. Okay, we've got 1x1. Okay. And then it says, notice the top row says minus twice x2, but x2 is found to be x3 minus 5. That's right. And then 1, so plus 1 x3 is 9. So x1 minus 2 x3 plus 10 plus x3 is 9. So guess what? x1 is found to be, let's see, that's minus, okay, it's going to be x3 minus 1 if I'm not mistaken with my math. Okay, no one said anything about x3. In fact, x2 is written in terms of x3, x1 is written in terms of x3. So the solution, we'll just write it this way for now. There's different ways of saying it, but the solution would simply be x1 is whatever x3 is, take away 1. And x2 is whatever x3 is, take away 5. And x3, the book says, is free. Free meaning free to be whatever you choose it to be. And that's how these guys go. I think we're done with that particular video. So we'll see you at the next one.